let's calculate the log base 3 of 1 over 243 without a calculator. Now, how do I know I can do this without a calculator, besides the fact that they told me to do it without a calculator? Well, maybe they didn't tell you, but you don't need a calculator, because this number I know is a power of 3. 243, if I think of 3 squared, think of the powers of 3. You got 3, you've got 9, you've got 27. If I multiply that by 3, I'll get 81. If I multiply that by 3, so that's to the 4th. So 3 to the 5th is 243. That's 3 to the 5th power, right? You probably should have the powers of 2 and 3 memorized at the very least, up to like maybe 5 powers of each of them or more. Okay. So that means this equals log base 3 of 1 over 3 to the 5th. And do you remember what happens when you have something in the denominator like this? What can you do to it?
Move it to the front.
Move it to the top and call it what? A negative, right? 3 to the negative 5. Does that make sense?
Yeah.
And what did I just say about logarithms? What did I explain to you in the last video? What does this mean? What can I do with this?
Bring it to the left.
I can bring it to the front.
Yeah.
So this is negative 5, and what's the log base 3 of 3? It's 1. So your answer is just negative 5. Okay, let's do the next one. What's the log base 3 of root 3? It's not 1. What's the square root mean? What does it mean to be a square root? You remember that a square root is actually a power? Do you remember it's the 1/2 power? So it's the 1/2 power. So this is the same as log base 3 of 3 to the 1/2 power. And again, what do I do with this?
Just 1/2.
That's right. I just drop it down. Got it? Let's try another one. What's the log base 4 of 0.25? Well, first of all, recognize that 0.25, I can write that as a fraction. How would I write that as a fraction? 1/4, right? And what's 4 again? That's 4 to the negative 1, right? 1 over 4 is like 4 to the negative 1, right? So the log base 4 of 4 to the negative 1, what do I do with the negative 1?
Bring it to the front.
Bring it down front, and then there's your answer. Okay, logarithms. Let's try another one. Log base 5 of 25. You can do that in your head now. Yep, it's just 2, because 25 is 5 squared. How about the log? This is trickier. The log base 49 of 7. That's trickier. That's trickier because you might think it's 1/2, but let's just check. Let's just check what this is. 49 is really 7 squared, right?
Yeah.
So this is like, so I'm gonna write it like this, and I'm gonna use, this is called an equivalence. Remember that thing I was teaching you in the last video? 49 to the y equals 7. 49 to the y equals 7. Does that make sense? How we went from logarithmic to exponential?
Yeah.
Now I can rewrite this as 7 squared. Right? What do I do with these two things up here? When I raise a power to a power, you remember what I do with them? Do I add them or multiply them?
Multiply.
Good. So that's 7 to the 2y equals 7 to the 1. And now what can I do with the 2y and the 1? I can set them equal to each other. 2y equals 1, and now I can, so you were right, it's 1/2. But I didn't want you just to assume that it was 1/2 because it kind of looked like it was. Like I wanted you to see the process of how you do that. Okay? So if I had the log 36 of root 6, same kind of deal. I'm going to rewrite this. I'm going to call that y. I'm going to rewrite this as 6 to the y equals 6 to the 1/2. I kind of took 2 things, right? Did 2 steps there. Got it? which is like saying 6 to the 2y equals 6 to the 1/2, which is like saying 2y equals 1/2, right?
Yeah.
Which means y equals, I'm going to divide both sides by 2. What would I get?
Oh,
1/4. Okay, see how we make those? See how we do this process?